the largest black holes. It started in silence, Antarctica, the year 2011. The South Pole Telescope scanned the darkness, expecting faint galaxies and scattered clusters. Instead, it caught something brighter, louder, almost violent, the Phoenix Cluster, a gathering of nearly 1,000 galaxies burning in X-ray light. But the brightness wasn't the shock. At the cluster's core lurked whispers of a black hole so massive it might outsize entire galaxies. Imagine an event horizon that could swallow our solar system not once, but dozens of times over. And here's the thing, only a small fraction of viewers ever subscribe. If you're still here, your curiosity sets you apart. Hit that button now, because the biggest discoveries are always hiding just over the horizon. But before Phoenix claimed the stage, there were contenders, rivals, heavyweights battling for the crown. For decades, IC 1101 was the reigning monster, a galaxy so vast, early estimates stretched it to nearly 6 million light-years across 60 Milky Ways end-to-end. At its swollen core, astronomers calculated a black hole weighing 40 billion suns. Think about that. An invisible sphere so wide, Neptune's orbit looks like a grain of sand inside it. Later revisions cast doubt, was it truly that massive, or just a legend of inflated numbers? Then came the crowd favorite TON 618. At first, it fooled astronomers. It looked like a simple blue star. But hidden in its glare was a quasar, a cosmic beacon powered by a black hole so greedy it devoured matter at 7,000 kilometers per second. Early models put its mass at 66 billion suns. That meant an event horizon stretching nearly 400 billion kilometers across 40 times the distance from the Sun to Neptune, too big to ignore. TON 618 became the people's champion, plastered across comparison charts, headlines, and late-night debates. And yet, Phoenix waits in the wings. Closer than TON 618, fiercer than IC 1101, its central black hole may be even larger, a true heavyweight hidden inside a 1,000-galaxy furnace. If Phoenix is real, if its numbers hold, then everything we thought had limits doesn't. Because here's the truth about black holes. Every time we crown a champion, a bigger shadow emerges. The gatekeepers. Most black holes stay invisible, but when they feed, the universe lights up. Jets of radiation fire across thousands of light years. Whole galaxies shift under their influence. And in that chaos is a question: what's the biggest monster really out there? Picture Phoenix. Its core should be silent, yet it blazes with new stars. Hundreds of them, igniting where science said they shouldn't. The very black hole that should be killing galaxies might also be creating them. A paradox, a cosmic crime scene. Stop and think. What would you do if the villain of the universe turned out to also be its architect? Because here's the emotional hook, these monsters are not just destroyers, they are gatekeepers. They decide which galaxies thrive and which ones fade. Every star we see in the night sky may have been chosen or denied by a black hole, breaking the rules. Remember that hint about Phoenix rewriting the laws? Here's the payoff. Surveys showed its core blazing brighter than anything like it powered by a black hole that should not exist. Old models swore black holes capped at 50 or 60 billion solar masses. Yet Phoenix laughs at that ceiling. According to the Astrophysical Journal, Phoenix isn't just unusual, it's impossible under old physics. Not speculation, data, peer-reviewed, verified. Now imagine it. Stars born by the hundreds, others torn apart, radiation flooding the void, a battlefield in the heart of a galaxy. Most people will never even care, but you do. You're still here. And that curiosity makes you part of the few who will know this story before it rewrites textbooks. Shadows without end. Here's the stake. If Phoenix is truly larger than TON 618 or IC 1101, then physics itself is on trial. If black holes can grow past their supposed limits, what else can? Galaxies? Universes? Our models may collapse like paper. And don't expect a neat ending. Each time we crown a champion, another shadow appears. TON 618 once ruled, IC 1101 challenged it, now Phoenix rises. Tomorrow, another name may steal the crown. So here's the truth, cut and simple. These monsters are not just records, they're warnings. They remind us we're ants debating mountains, or maybe flies circling a fire. And that fire? It's still growing. So ask yourself, if the largest black hole is still out there, hidden in the dark, don't you want to be the first to know? Subscribe now. Because the universe isn't done with us yet, and the next reveal could be bigger than all the rest. Where do these monsters come from? Stellar black holes are easy. They're born when stars at least 3 times heavier than the sun collapse in on themselves. But when we're talking about black holes billions of times heavier than the sun, the origin story is far less clear. One idea says they start small, as ordinary stellar black holes, and slowly fatten themselves over billions of years by devouring gas, dust, stars, and other black holes. But the math doesn't always work. To reach 40 or 60 billion solar masses, they would need to eat at a pace that physics itself tries to limit. Another possibility is more radical, that some of these giants were born big, collapsing directly from enormous clouds of primordial gas shortly after the Big Bang. If that's true, the universe's earliest moments weren't calm and gentle. They were violent, birthing monsters from the start. Which story is real? The answer changes everything about how we understand the history of galaxies and our place inside them. Black holes are invisible. By definition, no light escapes them. So how do we know they're there? Sometimes it's the way they bend the space around them. Sometimes it's the glow of material being devoured. And sometimes we don't see them at all, we hear them. In 2015, scientists made history. Using the Laser Interferometer Gravitational Wave Observatory, or LIGO, they detected faint ripples in space-time gravitational waves. Those waves were created when 2 black holes spiraled into each other and merged. Think about that. The collision of invisible objects billions of light years away shook the fabric of the universe hard enough for us to feel it here on Earth. Every wave we detect is like a drumbeat from the cosmos, proof that these monsters don't just exist, they dance, they fight, they collide. If Phoenix or Ton 618 ever merged with another heavyweight, the echo would rattle space-time itself, and one day, we may be here to hear it. Why it matters. It's easy to treat this like cosmic trivia, numbers so big they stop meaning anything. But here's the truth. Black holes matter because they decide the fate of galaxies. Without them, the Milky Way might never have taken its spiral shape. Without them, the gas clouds that formed Earth might never have gathered. Every galaxy you've ever seen, every twinkle of light in the night sky, may owe its existence to a central black hole. They are engines of destruction, yes, but also engines of creation. The paradox at the heart of Phoenix destroying and creating stars at once may be the story of the entire universe. And that's why the search for the largest black hole isn't just about bragging rights. It's about understanding how everything we know came to be. The bigger they get, the more they force us to admit how small we are and how powerful our curiosity can be. That curiosity is the reason we can stand on this tiny planet, look up at the sky, and dare to ask, what's hiding out there in the dark?